In this example, we're going to have a look at how to factorise a quadratic trinomial where the coefficient of the squared term is not equal to 1. This process does require you to be confident with your algebra. Make sure you're also prepared to show your steps in working out. In this example, we're being asked to factorise 3x squared plus x minus 10. The first thing we do is look for a common factor. If we can take out the coefficient of the x squared as a common factor, it does make the whole process easier, as we've seen in previous examples. Since there is no common factor, we need to adopt another method. The quick method looks at the n terms, or in other words, the squared term, in this case 3x squared, and the constant by itself, in this case negative 10. What we need to do is write down two pairs of brackets and then try to multiply to those n terms. In the first case, the only two numbers that multiply to 3 are 3 and 1. And we have to have an x in each bracket if we're going to factorise this in terms of a quadratic trinomial. So our first two terms in each bracket are 3x and x. If we multiply these terms, we get back to our first term of the original expression, which is 3x squared. The next thing to do is to consider the second part of each bracket, knowing that they have to multiply to negative 10. To make life easier for us, we'll first of all consider it as just positive 10. So we're asking ourselves what two numbers multiply to 10. Two pairs of numbers that do that are 1 and 10 and 2 and 5. We'll list those, and now what we have to do is a trial and error process to see which works. We'll try 1 and 10 first, and we'll multiply out these brackets, again ignoring the negative for the moment. Our aim, of course, is to see if we can get back to the original expression. Let's multiply 3x by x first of all. That gives us 3x squared. 3x multiplied by 10 gives us 30x. 1 multiplied by x is 1x, and the last pair is to multiply 1 and 10, and that gives us 10. Our aim now is to look at these terms and see if they can give us back the original expression. Certainly the 3x squared and the 10 work, but there's no way that the 30 and the 1x can combine to give us plus 1x as the middle term. Let's take that same working out and put it in another format, which will be easier to use for future trials. You can see that the first bracket we've put in orange, 3x and 1, and the second bracket, x and 10, we've put that in green below the brackets. What we effectively do is a diagonal multiplication. We can see we've got 3x and 10 in orange and x and 1 in blue, because the sum of those products should match the middle term of our quadratic trinomial. You can see that 3x and 10 multiply to 30x, x and 1 multiply to x, so 30 and x should combine to make positive x, shown in green. Unfortunately they don't, so we'll have to try another option to see if we can get the correct solution in the brackets. Keeping in mind the n terms of the brackets must multiply to 10, another option would be to switch the 1 and the 10 around and make them 10 and 1 in the brackets. So we'll change those. When we do our diagonal multiplication, we get 3x multiplied by 1 is 3x, x and 10 multiply to be 10x, and again there's no way to actually make those two products add up or subtract towards positive x. So let's summarise those efforts as if we're putting them on paper. We can see that we've got 3x and x in one column. That product represents 3x squared in our quadratic trinomial. We can see that we've got other pairs of numbers and they must multiply to 10. We've tried 1 and 10, and then we've tried 10 and 1, and now we need to try another combination, in this case 5 and 2. Multiplying across in the colours, we can see that x and 5 multiply to 5x, and in orange 3x and 2 multiply to 6x. So our aim is to make those two terms come towards positive x in some way, and we can do that using subtraction, 6x minus 5x. So we need to make the 5x negative, and that means we need to put a negative sign in front of the 5. So now we have arrived at our solution, and the two brackets are 3x minus 5 and x plus 2. And it would be wise to go through and expand those brackets and check to see if it actually comes to the original quadratic trinomial.